Hey guys, welcome to my channel. In the United States, when people talk about infrastructure, what often comes to mind are icons like the Golden Gate Bridge or the aging yet vital interstate highways that still keep the country moving. But halfway across the world, in China, a different kind of infrastructure story is unfolding. One defined by jaw-dropping speed, sheer scale, and world-shaping ambition. China's engineering achievements are not only transforming the nation's own development map, but also quietly rewriting the rules of global infrastructure. Today, we're taking you deep inside this story to uncover the secrets behind China's rise as a global infrastructure powerhouse, and to witness the extraordinary legacy it's building in steel, stone, and ambition. When the People's Republic of China was first founded, the country's infrastructure was practically non-existent. The railway network was limited and outdated, with old equipment and low technical standards. Most roads were made of dirt or gravel, and many remote regions weren't connected by any roads at all. Bridge construction lagged far behind, unable to meet even the most basic transportation and economic needs. But the Chinese people have always carried a deep resilience and a determination to build a better future. While many Western nations remain stuck in debates over whether to renovate or replace aging infrastructure, and often hesitate to take on major projects due to soaring costs and technical complexity, millions of Americans hitting the road will cross bridges and roadways in dire need of improvement and repairs. Getting to your destination likely won't be easy. Expect traffic jams, because decades-old bridges and roads weren't built to handle today's traffic. The American Society of Civil Engineers once gave the nation's infrastructure a grade of D+. And that's more than just a letter, it's a warning sign for everyday commuters. A looming crisis is quietly unfolding. More than 1 in 9 bridges across the United States has been classified as structurally deficient. Many roads are severely outdated and simply can't handle the overwhelming traffic volumes of today. Former U.S. Transportation Secretary Anthony Fox put it bluntly: if we fail to invest in and maintain our aging roads and bridges, the American people will pay a heavy price. It's not just about safety. An estimated 1 million jobs are also at risk. Studies reveal a startling economic impact. Traffic congestion alone costs the U.S. over $20 billion annually in wasted fuel. On average, each driver loses more than $8,000 every year, not just in dollars, but in time, productivity, and quality of life. Even more concerning is the Highway Trust Fund, the primary source of funding for transportation infrastructure. It's largely supported by an 18.4 cent per gallon gas tax, a rate that hasn't been adjusted for inflation since 1993. The result? A critical funding shortfall that's only growing worse by the year. Although the United States is aware of these issues and shows a willingness to improve, it often chooses to maintain the status quo in the face of high renovation costs and complex interest struggles. While the U.S. struggles to maintain what it once built, China is doing something different. It's moving forward, fast. With astonishing speed and creativity, China is breaking world records again and again, reshaping its economy, its geography, and perhaps even the global balance of development. This kind of efficiency and innovation was on full display during the 2015 reconstruction of Beijing's Sanyuan Bridge. In Beijing's vast transportation network, Sanyuan Bridge is a critical hub. Built in 1984, it's a diamond-shaped interchange located at a key traffic junction. Every day, it carries an enormous volume of vehicles. At peak hours, up to 13,000 cars pass over the bridge each hour. 48 bus lines run through it, serving an average of 727,000 passengers daily. After decades of intense use, serious structural problems emerged. The main beams and deck panels had deteriorated significantly, and the bridge's load-bearing capacity dropped to an unsafe level. In 2015, it was classified as structurally deficient. That November, Beijing launched a high-stakes renovation project. Under conventional construction methods, the project could have taken several months, causing major traffic disruption in one of the city's busiest corridors. But Chinese engineers had a different plan. They adopted a bold and innovative approach, replacing the bridge deck as a whole using a 1,000-ton integrated transport lifting machine. The old bridge deck, weighing 1,006 tons, had to be removed in 2 massive sections. The new deck, weighing over 1,003 tons, had to be transported and installed with centimeter-level precision. The challenges were non-stop. Once work began, engineers found the old bridge in even worse condition than expected. Its concrete was badly damaged and structurally unstable, making safe removal in one piece impossible. The command team quickly switched to a contingency plan, on-site dismantling and segmented transport. Space at the construction site was extremely limited. There were multiple crews, large machines, high-precision demands, and the work had to be done during off-peak hours to avoid shutting down major roads. But through the tireless efforts of over 1,000 workers operating in shifts, the impossible became reality. The entire reconstruction, from launch to reopening, took just 43 hours. A professor from a top UK engineering university even cited the Sanyuan Bridge project in his lectures, calling it a textbook example of engineering efficiency. He told his students plainly,
China has actually soared. It's meteoric. Former Czech President Václav Havel, I think, put it best. He said, all this has happened so fast, we haven't yet had time to be astonished. To remind myself how astonished I should be, I occasionally look out the window in my office in Cambridge at this bridge, which goes across the Charles River between the Kennedy School and Harvard Business School. In 2012, the state of Massachusetts said they were going to renovate this bridge. It would take 2 years. In 2014, they said it wasn't finished. In 2015, they said it would take 1 more year. In 2015, they said it's not finished. We're not going to tell you when it's going to be finished. Finally, last year, it was finished 3 times over budget. Now, compare this to a similar bridge that I drove across last month in Beijing. It's called the Shenyang Bridge. In 2015, the Chinese decided they wanted to renovate that bridge. It actually has twice as many lanes of traffic. How long did it take for them to complete the project? 2015. What do you bet? Take a guess. Okay, take a look. The answer is 43 hours. Now, of course, that couldn't happen in New York. Yes. Okay. Behind this speed and execution is a purpose-driven leader and a government that works. The most ambitious and most competent leader on the international stage today is China's President Xi Jinping. And he's made no secret about what he wants. As he said when he became president 6 years ago, his goal is to make China great again.
Nice. The success of the Sanyuan Bridge project quickly went viral. Time-lapse videos of the operation racked up millions of views worldwide. American netizens couldn't believe their eyes. Is China in cheat mode? What takes us 3 years, they finish in 43 hours. My country should really learn from China's attitude and speed when it comes to infrastructure. This is how you serve the people. If this were New York, just getting the permit would take 7 years. Others compared it to their local transit woes. Look at our New York subway, outdated and crumbling, but no one can agree on how to fix it.
What? What the fuck?
Meanwhile, China just gets it done. I've been to China, and to this day, I'm still blown away by their subway system. Step into a metro station in Shenzhen, and it feels like you've entered the future. The marble floors gleam like mirrors under soft, ambient lighting. There's a faint, pleasant scent in the air. Every corner is spotless, literally not a speck of dust in sight. Inside the train cars, the leather seats are plush and comfortable. High-definition screens provide real-time updates, and even the station announcements are delivered in a calm, elegant, almost futuristic tone.
欢迎乘坐深圳地铁。欢迎乘坐深圳地铁。
Welcome to Shenzhen Metro. This train is bound for Bito, Gangsha North. Passengers can transfer to Line 2, Line 10, or Line 14.
From the artistic murals lining the transfer corridors to the smart navigation kiosks scattered throughout the stations, everything feels thoughtfully designed and incredibly user-friendly. Now follow my lens, and let's explore some of the most beautiful subway stations in China. Then I flew back to New York, and reality hit me like a cold slap. The subway platforms here reek of mold and a strange mix of garbage and stale air.
I've seen rats, I've seen old garbage, I've seen all types of stuff in the subway.
I would say the grossest thing I've seen on subways is definitely human feces.
The walls are covered in peeling paint and faded graffiti that look like they've been there for decades. Rust-covered tracks are practically a highway for rats, and leaking ceilings drip steadily onto the already grimy floors. Inside the train cars, the seats are cracked and frayed, the windows spiderwebbed with scratches, and in the summer it feels like a sauna, while winter turns every ride into a freezing ordeal. No wonder people joke that New York's subway is a living historical artifact, while China's subway system is already racing toward the future. Of course, some American netizens responded with a more rational take. There was a time when the US led the world in infrastructure. Just look at the Empire State Building. Its construction speed once stunned the world. Groundbreaking began on March 17, 1930, and the building officially opened it on May 1, 1931. That's just about 1 year and 45 days. It was hailed as a miracle in architectural history. During construction, the team used highly efficient methods and techniques, setting a record for building speed at the time. But now we've clearly fallen behind. Once a proud symbol of America's infrastructure prowess, the Empire State Building now sits surrounded by signs of neglect. The roads around it are riddled with potholes and cracks due to years of undermaintenance. Vehicles jolt and rattle as they pass, a stark contrast to the glamour of New York City. The former Pakistani Prime Minister Imran Khan knows this phenomenon all too well. He said,
"While the US was pouring money in Afghanistan in this futile war, the Chinese were developing first world infrastructure, and you just have to go to China to see the way their infrastructure is." And I'm in New York, and I'm watching the car bumping around here. That money was wasted.
This isn't an isolated case. Across the US, road conditions are in decline. According to the American Society of Civil Engineers, more than 40% of highways nationwide are rated as poor or merely mediocre. Aging roads have also led to increasing traffic congestion, adding an average of 54 extra commuting hours per year for American workers. The United States' performance in bridge infrastructure is also deeply concerning. In March 2024, the Francis Scott Key Bridge in Baltimore, Maryland, collapsed after being struck by a ship. This bridge, built in 1997, is nearing the 50-year design lifespan, typical of most bridges in the United States. According to a 2021 report by the American Society of Civil Engineers, approximately 42% of U.S. bridges have been in service for over 50 years, and around 12% are 80 years old or more, posing significant safety risks due to aging infrastructure. In contrast, China's 43-hour bridge swap at Beijing's Sanyuan Bridge stands as a feat of engineering and efficiency. While the U.S. was once a global leader in infrastructure, it now faces chronic underfunding, lengthy decision-making processes, and strained local budgets, all of which hamper progress. In an attempt to reverse the decline of America's infrastructure, former President Biden signed the Infrastructure Investment and Jobs Act at the White House, hoping to revitalize the nation's infrastructure through this initiative.
Across our country right now, there are 45,000 bridges, 45,000 that are in poor condition. We're seeing photos of some of them behind me in all 50 states. And I've had a chance to see some of them myself as I've traveled the country. But about 2/3 of the bridges in need of repair in this country are considered what they call off-system because they're not directly connected to the interstate highway system. These are the bridges that are often overlooked when decisions are being made, but they are essential for small towns, rural towns, farmers to get their products to market, small businesses to be able to serve customers. These are the bridges that, when they're closed, shut off deliveries and routes to school, work, and home. They create longer delays for first responders when every second counts. So we've included $27.5 billion for smaller bridges, including dedicated funding for those off-system bridges I just described. And because maintaining these bridges is often the responsibility of counties or towns whose budgets are stretched thin already, we decided to get rid of the requirement that counties or towns share in the cost. The federal government is going to pay for 100% of the cost for repairing these small bridges.
However, due to various challenges, the rollout of funding has been slow, making it difficult to close the massive infrastructure financing gap.
Oh, God, please, no! No!
America's golden era of infrastructure is fading into the past, while China charges forward, drawing a sharp and undeniable contrast. The Sanyuan Bridge project became more than just a construction story. It was a showcase of Chinese engineering skill, the power of Chinese speed and precision, and a statement to the world. When it comes to infrastructure, China isn't just catching up, it's setting the pace. From the world's largest high-speed rail network, spanning over 42,000 kilometers, to the record-breaking Hong Kong-Zhuhai-Macau Bridge that links 3 major cities across the sea. From the Sichuan-Tibet Railway cutting through the treacherous Hengduan Mountains, to the breathtaking Beijing-Daxing International Airport with its Phoenix-inspired design. Through sheer ambition and engineering excellence, China has redefined what it means to be an infrastructure maniac. Now, another monumental project is steadily advancing, the Pinglu Canal. This colossal undertaking is ushering in a new era of construction and national development on an unprecedented scale. In the towering mountains of southwestern China, engineers are carving a massive 135-kilometer canal, cutting straight through rugged terrain to give landlocked cities in Guangxi direct waterway access to the South China Sea. This isn't just about digging a ditch. This is a bold gamble to reshape the region's economic lifeline. It's called the Pinglu Canal, and it's being hailed as the artery of the century. Right now, it's turning this once unthinkable plan into reality. The scale of excavation is nothing short of staggering. Over 340 million cubic meters of earth and rock are being moved, the equivalent of shaving down entire mountain ranges. That's 3 times the excavation volume of the Panama Canal. At one of the most challenging sections, the Madao watershed, engineers are dealing with a 30-meter elevation difference, blasting through rock and flattening channels like performing surgery on the earth itself. Once completed, this canal will become a new express waterway, connecting the upper reaches of the Xinjiang River directly to the sea. Shipping routes from China's southwest to the ocean will be 560 kilometers shorter, saving billions in logistics costs annually. Take Nanning, for example. Cargo will reach the sea 7 days faster, and logistics costs could drop by 30%. But the canal is more than a regional shortcut. As a key node in the maritime Silk Road, it will deepen trade between Southwest China and ASEAN countries. It will also strengthen ties across China's Belt and Road, linking the Beibu Gulf Economic Zone, the Chengdu-Chongqing Economic Circle, and the Greater Bay Area, creating an international industrial corridor and sparking economic takeoff across multiple regions. When foreign viewers first saw drone footage of the construction site, many thought they were watching a sci-fi movie or footage of an alien base. A European viewer commented, "This isn't just building a canal, this is redrawing the map of regional economics." China's vision and execution are absolutely mind-blowing. One American viewer was stunned. "Are we still on Earth? This looks like a base on the moon. The CGI is so real, no wonder people thought it was fake." But once they confirmed it was a real project, the tone changed. This is master-class engineering. This is how you make a nation great, not by slogans, but by building something that speaks for itself. A German viewer marveled, "I'm speechless. Where is this exactly? I'd love to visit someday." When people learned that canal is expected to be completed by 2026, the comment sections lit up with comparisons. An Australian joked, This would take us about 400 years to finish down here. And an American chimed in, on a construction site here, we have 20 workers. 1 works and 19 supervise. The contrast with China's construction efficiency couldn't be more stark. A Dutch hydraulic engineer named Jan commented, "Coming from a country that has lived with water all its life, I've never seen something this wild and precise at the same time." Meanwhile, a US viewer wrote, "Our infrastructure proposals are still stuck in Congress. China's out here slicing the continent in half with a canal. I surrender. That's execution." If the Pinglu Canal is China's way of rewriting legends into the land, then the Sichuan-Tibet Railway is about challenging the limits of engineering on the rooftop of the world. Spanning 1838 kilometers and reaching altitudes of up to 4,400 meters, the railway must cross 14 seismic fault lines, making it one of the most difficult rail projects ever attempted on Earth. To solve the challenges of building on permafrost in high-altitude regions, Chinese engineers developed an innovative thermal siphon cooling system. By harnessing the principle of ammonia's thermal expansion and contraction, the system draws underground heat away, keeping the frozen soil layer stable. For bridge construction in these harsh environments, they use lightweight alpine steel structures that are 30% lighter than traditional steel, yet strong enough to withstand Category 12 of winds and magnitude 8 earthquakes. During the construction of the Erlong Mountain Tunnel, workers wore oxygen tanks on their backs and used pneumatic drills to chip away at the solid rock, inch by inch, enduring temperatures as low as -20 degrees Celsius. They went on to set a world record, advancing 350 meters in a single month under such extreme conditions. The completion of the Sichuan-Tibet Railway will dramatically improve connectivity between Tibet and the rest of China, boosting economic development, cultural exchange, and helping lift communities along the road out of poverty. Railway enthusiasts across the West have praised it as a monumental victory of mankind over nature. Some even called it a miracle built in one of the most impossible environments on Earth. However, certain Western media outlets and commentators have painted a different picture. Some labeled the railway one of the most expensive projects in the world, implying that China is overspending to show off. Others linked it to the 100th anniversary of the Communist Party, calling it a lavish political gift. There have even been rumors claiming the railway will destroy local traditions by flooding the region with tourists, or that the Chinese military might use it to threaten neighboring countries. But these claims are baseless, rooted in prejudice and jealousy, not facts. Throughout the long and storied history of human engineering, tales of pain and sacrifice have never been absent. In the 1930s, during the construction of the Hoover Dam in the United States, 120 lives were lost to the cold grip of concrete, and countless more were injured. At the Panama Canal, tens of thousands of workers perished, 30,000 men, claimed by the deadly combination of tropical disease and grueling labor under the sweltering jungle heat. Looking further back, China's Great Wall, winding across the mountains for thousands of miles, was built atop an immeasurable human cost. Buried beneath the earth and stone are the silent remains of those who gave their lives, whispering stories of suffering beneath each brick and battlement. But with time, the meaning of engineering has evolved. In modern-day China, the principle of people first, life above all, has become central to every project. Every life is treated as invaluable. This deep respect for human life was fully embodied in the construction of the Qinghai-Tibet Railway, the world's highest altitude rail line, built across the Tibetan Plateau at an average elevation of 4,000 meters. As soon as construction began on this sky road, it presented an unprecedented challenge to the nation's medical and safety systems. In this forbidden zone of life, where thin air and sub-zero temperatures can silently claim a life within moments, even a single breath carried potential danger.
那么进入高原以后呢，它的早期的表现呢，一般都是头疼、恶心、心率加快、呕吐这些症状。
But Chinese builders did not choose to push forward at the cost of lives. Instead, they drew a line of defense with science, planning, and care. On a site with over 200,000 workers, medical teams were stationed throughout every stage of the project. Portable oxygen generators, mobile treatment units, regular health checkups, and emergency response systems were deployed to every work zone. Every protocol reflected a commitment to life, every detail a testament to the value placed on human dignity. In the end, China not only conquered 3 world-class engineering challenges, permafrost, extreme altitude, and fragile ecosystems, but also achieved a miracle in safety: 0 deaths from altitude sickness. This wasn't just a victory for engineering. It was a living demonstration of a core belief that no achievement is worth more than a single human life, and that even in the pursuit of national development, China will never compromise on protecting its people. The construction of the Qinghai-Tibet Railway is widely regarded as one of the greatest feats in the history of global railway engineering. However, during its development, some Western media outlets went to great lengths to exaggerate claims of casualties during the project, attempting to distort the true meaning and significance behind China's efforts in building this monumental railway. Their coverage was often laced with sarcasm and suspicion, as if struggling to accept that China had managed to complete a project of such extreme technical and geographical difficulty. Some foreign netizens also echoed false narratives. One South Korean commenter even claimed that if Korea had built this railway, it would have taken half the time, while also alleging that over 3,000 workers died from altitude sickness. But the truth tells a very different story. During the first phase of the Qinghai-Tibet Railway, it's true that China faced harsh environmental conditions and lacked the advanced resources we have today. According to official data, 179 workers lost their lives, and 633 were injured during this early stage, when engineers had to battle severe permafrost, high altitude, and extreme weather with limited technology. But by the time construction of the second phase began in 2001, the situation had changed dramatically. China's financial, technical, and medical capabilities had all improved significantly. Participating construction firms implemented comprehensive health and safety systems to protect every worker involved. Dr. John West, Vice President of the International Society for High Altitude Medicine, described the Golmud Lhasa section of the railway as one of the most challenging high-altitude projects ever built. Comparable, in his words, to the Great Wall of China in the sky. China invested heavily in studying and treating acute and chronic altitude sickness, building a full medical infrastructure around the project. They promoted on-site emergency care protocols, which dramatically reduced the incidence of deadly conditions such as high-altitude cerebral edema and pulmonary edema. Over 3 years of continuous construction, more than 100,000 workers took part in building the railway, and not a single life was lost due to altitude-related illness. This shocked even Western medical experts. A Chinese Academy of Engineering academic later pointed out, when the project reached elevations above 4,500 meters, we had 14,000 people working, and not a single death from hypoxia. Ironically, over 100 fatalities occurred due to car tire blowouts, not from altitude. To fight oxygen deprivation, construction teams deployed everything, from personal oxygen bags, to cylinders, to oxygen generation stations, and even hyperbaric chambers. Over the 5 years of Phase 2 construction, workers used up 600,000 oxygen tanks, a powerful symbol of how science and compassion came together to protect lives. The Qinghai-Tibet Railway was not just an engineering triumph. It was a triumph of will, science, and deep respect for life. Those who try to discredit it with false claims are quickly silenced by the facts. This railway has become more than just a symbol of China's infrastructure strength. It represents humanity's victory in confronting the limits of nature without sacrificing human dignity. Still, some Western media continue to label the project as a political stunt. They claim it was built merely to elevate China's leadership image, ignoring the deeper purpose behind it: to promote regional development, connect remote areas, and foster national unity. In one article, the New York Times argued that the railway would accelerate Han-led economic development in Tibet and claimed it would choke the region's ancient spiritual civilization. They even warned that the railway might further accelerate the migration of Han Chinese into Tibet, calling it a tool for state control. Some Western media even went so far as to claim that the Qinghai-Tibet Railway threatens the very existence of Tibetan and Buddhist culture. Tibetans' unique way of life will disappear. That was their warning. But what do you think? Do these narratives reflect reality, or are they fueled by misunderstanding and bias? Let us know your thoughts in the comments below. We'd love to hear your perspective on this project and what it truly represents for China, for Tibet, and for the world. So how is China defining the next century of human progress? While the US is still fixing highways from the last century, China is already exploring the ultimate future of infrastructure. In the US, crumbling bridges and delayed trains are increasingly seen as just the way things are. According to the American Society of Civil Engineers, around 43% of all bridges in the country are over 50 years old. Many are even classified as structurally deficient. Meanwhile, across the Pacific, China is rewriting the rules of infrastructure. In 2023 alone, over 10,000 bridges were built or rebuilt, some of them world-class megastructures that span entire seas. The contrast in transportation infrastructure is even more striking. In New York City, the subway averages just 16 km/h, and delays caused by aging equipment are a daily occurrence. Meanwhile, China's high-speed rail network races ahead at 356 km/h, with a total length exceeding 45,000 kilometers, accounting for more than 70% of the world's high-speed rail mileage. Take California's high-speed rail as an example. After 15 years of planning and debate, only a 190-kilometer stretch has been completed, with costs ballooning from $33 billion to over $128 billion. In contrast, China builds comparable rail lines in 40% less time and at 30% lower cost, without compromising quality or safety. The gap is just as visible in energy infrastructure. In parts of the U.S., aging power grids struggle to withstand extreme weather, often resulting in widespread blackouts. Meanwhile, China has built the world's largest clean energy system. Just one facility, the Baihetan Hydropower Station, can supply electricity to over 40 million households. While the U.S. is still debating pipeline repairs, China has already completed thousands of kilometers of natural gas and oil pipelines, meeting the world's highest technical and construction standards. Behind these numbers lies a fundamental difference in development models. In the U.S., infrastructure projects often stall amid lengthy approval processes and political gridlock. In China, powerful coordination, homegrown engineering innovation, and a long-term vision turn blueprints into reality at scale and speed. Want to know how these engineering miracles come to life? Let's dive into the construction front lines of some of China's most awe-inspiring projects, like the Deep Earth Tacor 1, the Zhenjiang High-Speed Railway Tunnel, and the Changtai Yangtze River Bridge, and see what the future of infrastructure really looks like. In today's global infrastructure landscape, China is redefining what's possible, building at a speed and scale that is simply breathtaking. While many nations struggle to repair or upgrade aging infrastructure, China has launched a sweeping infrastructure revolution, reshaping geography and transforming lives through one mega project after another. In the remote Tarim Basin of Xinjiang, the roar of drilling machines never stops at the Deep Earth Taklamakan 1 well. This is no ordinary project. It's a direct challenge to the Earth's limits. While shale gas drilling in the United States hovers around 3,000 meters, Chinese engineers, using an entirely domestically developed automated rig, have pushed the drill bit to a staggering 1,910 meters below ground. This makes the Taklamakan 1 well the deepest in Asia and the second deepest scientific borehole in the world. It also marks a historic breakthrough in China's deep earth exploration capabilities. Engineers faced extreme heat, pressure, and complex geological formations, yet they overcame these with relentless innovation. Every meter drilled pushed the boundaries of what humans can achieve. It is said that after drilling 9,000 meters underground at the Deep Earth Tacor 1 well, Chinese engineers broke through rock layers that date back 500 million years. They then converted seismic waveforms from 9,000 to 14,000 meters below the surface into audible frequencies, allowing us to hear the sounds from deep within the Earth. Meanwhile, under the Pearl River estuary, the construction of the Zhenjiang High-Speed Railway Tunnel is just as intense. At a depth of 106 meters beneath the seabed, the massive Zhenjiang tunnel boring machine is advancing at a steady 15 meters per day. This project has already broken records, becoming the deepest shield tunneling project in the world for high-speed rail. While New York's century-old subway tunnels often experience delays due to aging infrastructure, China has reached a 100% localization rate for TBM technology. From design and manufacturing to deployment, every step is domestically driven. This tunnel not only broke depth records, but also set 5 global engineering benchmarks, including breakthroughs in cable imaging and tailpipe grouting. These advances have significantly improved construction efficiency, safety, and reliability. Even the New York Times couldn't help but express amazement. In the Pearl River estuary, Chinese engineers connected 6.7 kilometers of undersea tunnel segments with a margin of error of just 3 millimeters, like assembling the Lego blocks in the middle of the Pacific Ocean. Meanwhile, Boston's Big Dig overran its budget by 220% and resulted in a fatal ceiling collapse. Now shift your view to the Yangtze River, where the Changtai-Yangtze River Bridge is rewriting engineering history. Its 350-meter-tall cable-stayed tower, equal to a 115-story building, is now the tallest of its kind in the world. But it's not just the height that impresses. The bridge's innovative flat-deck design integrates high-speed rail, expressways, and local roads all on a single level, maximizing efficiency and minimizing land use. The main waterway bridge of this river-crossing channel is a cable-stayed bridge with a main span of 1,176 meters. While both Tianxingzhou Channel Bridge and Luanzhou Channel Bridge use a steel truss arch bridge with a main span of 388 meters. Its average area is approximately 5,400 square meters, which is the size of 13 basketball courts. The underwater foundation for the tower piers of the bridge uses 23,000 tons of steel. That's the steel of 3 Eiffel Towers. Engineers faced enormous challenges, such as maintaining vertical precision for ultra-tall towers and hoisting enormous steel beams across vast spans. Yet, through cutting-edge techniques and bold innovation, these obstacles were conquered. In stark contrast, California's high-speed rail project remains mired in cost overruns and technical delays. China, by comparison, is completing similar projects 40% faster and at 30% less cost, thanks to its powerful industrial base, streamlined coordination, and decades of accumulated engineering expertise. But these mega projects are just part of the picture. China's infrastructure miracle is also evident in its expanding transportation network. As of today, China's high-speed rail network has surpassed 25,000 miles, more than 70% of the global total. From the icy plains of Harbin to the tropical shores of Sanya, from coastal megacities like Shanghai to the high-altitude plateau of Lhasa, this network crisscrosses the country like a web of steel dragons, uniting cities and boosting regional economies. These rail lines have dramatically reduced travel times and improved quality of life, while also driving regional economic integration. Throughout the process, engineers have tackled an array of extreme challenges: Arctic cold, searing heat, fragile ecosystems, deserts, and more. For example, the Qinghai-Tibet Railway posed 3 world-class challenges: high-altitude hypoxia, permafrost, and environmental fragility. Chinese engineers responded with pioneering solutions like elevated bridges in place of roadbeds, ventilated stone foundations, and thermal stabilizing rods, ensuring the safe and sustainable operation of one of the most remarkable railways on Earth. China's bridge building capabilities are equally remarkable. Beyond the Changtai-Yangtze River Bridge, a growing list of world-class bridges continue to break records. For instance, the Beipanjiang Bridge, with a vertical clearance of 565.4 meters from deck to riverbed, holds the title of the world's highest bridge. The Hutong-Yangtze River Bridge, spanning 1,092 meters, is the world's first cable-stayed bridge combining both railway and highway functions with a span exceeding 1 kilometer. The construction of these bridges not only demonstrates China's world-leading expertise in bridge engineering, but also reflects the spirit of bold innovation and technical ambition among Chinese engineers. In these projects, China has adopted a variety of advanced structural designs such as suspension bridges, cable-stayed bridges, and arch bridges. It has also employed cutting-edge construction methods, including prefabricated assembly, incremental launching, and bridge rotation. These techniques have significantly improved construction efficiency and quality across the nation. From cross-sea bridges to hydropower giants, from high-speed rail networks to clean energy megabases, Chinese engineers are pushing boundaries again and again, turning the impossible into reality. They are building, quite literally, the backbone of a nation's rise. These projects show that China doesn't just export infrastructure, it exports a complete development solution. Even the New York Times admitted Chinese infrastructure is reshaping the global economic order. So how is China defining the next century of human progress? While the US is still fixing highways from the last century, China is already exploring the ultimate future of infrastructure. As of 2023, China has built over 42,000 kilometers of high-speed rail, more than the rest of the world combined. To put that in perspective, if you connected all that track end to end, it would circle the Earth once. And it's not just about the numbers, it's about the speed of construction. Take Beijing Daxing International Airport, for example. With a $12 billion budget and a terminal the size of 97 football fields, the entire project was completed in just 4 years. But this isn't just architecture. It's a national strategy designed to connect 1.4 billion people and energize the economies of all 34 provincial regions. In the US, the picture looks very different. According to the American Society of Civil Engineers, 65% of US roads are in poor or mediocre condition, and over 45,000 bridges need major repairs.
Roads and bridges are vital to the country. The ability to freely move goods, services, and people across our nation directly contributes to our economic place in the world.
There's no question we're not making adequate investments in our transportation infrastructure. It's more expensive today to maintain what we have than it was to build it originally.
We're still driving on roads that my grandparents paid for and built. Our average bridge age is 75 years. Well, they were built to be 50-year bridges. One bridge that carries 90,000 cars a day. The nearest detour is an 11-mile detour. So if that bridge had to shut down, we'd be looking at 1 million miles a day of extra traffic while that bridge was shut down and being rebuilt.
The majority of our population lives in metropolitan areas, so our highways are greatly congested.
When you have congestion problems, time is money, and that's money lost to that business that is trying to get their product to the marketplace. Same thing for a business person whose time is very valuable.
We all work somewhere, and all of those jobs are dependent on that infrastructure working for us.
We need to make some more investments for the future. We have to look at the whole problem.
We have been working for many, many years, over a decade, to bring down the current long structure of a bridge down to street level, to turn that into a boulevard. And of course, the other side of that coin is if you don't invest in your infrastructure, and you do have bad roads, and you do have bad bridges, it doesn't help you with economic development.
Meanwhile, China's road network quality ranks among the top 30 globally. The difference is even starker in high-speed rail. While China's trains zip at 421 kilometers per hour, the US has no true high-speed rail network. It is shocking and incredible that the latest bullet train developed in China can reach an amazing speed of 603 kilometers per hour. Amtrak's Acela, often called high-speed, tops out at just 240 km/h, and that's only on a short stretch between Boston and Washington, D.C. This gap in infrastructure doesn't just highlight differences in engineering capability, it reveals two completely different development philosophies and system advantages. In the U.S., infrastructure has long been trapped in a vicious cycle: political gridlock, funding shortages, and delayed maintenance. Responsibilities between local and federal governments are often unclear, and interstate projects face endless red tape, leaving roads and bridges operating far beyond their intended lifespans, with little hope for timely repair.
We're going to start spending on infrastructure big, and not like we have a choice. It's not like, oh, gee, let's hold it off. Our highways, our bridges are unsafe.
The federal government's role in infrastructure is fairly narrow to certain types of things: interstate highways, major roads, and bridges. Infrastructure encompasses much more than that. It includes things like the electric grid, which is privately owned for the most part. It includes water and sewer lines, which are mostly owned by municipalities, local streets. Right now, some of the biggest needs are water and sewer systems in local governments. Many of those places, like Flint, Michigan, they're very poor cities. If they raise water and sewer rates, it's going to be poor people paying them.
The president has said that not all of the $1 trillion will come from the federal government, that he would like to see private capital also contribute. So is there money in the form of private capital to help with the infrastructure needs in the country? The answer is absolutely yes. The question is, are there attractive returns? Because those investors have many places that they can invest their money.
In terms of basic ways that you can pay for infrastructure, you can simply raise taxes and pay for it with cash. What happens if the toll money falls short? Bonds have to be paid back. Private investors want to make a return. So really, the people who are going to be paying for it is us, either in the form of higher taxes, higher fees, higher tolls. There's just no such thing as free money.
China, on the other hand, leverages its centralized coordination system, allowing for long-term planning and rapid execution. As a result, highways and railways have undergone explosive growth. Today, China's total expressway mileage ranks #1 in the world for consecutive years. Its 8 vertical and 8 horizontal high-speed rail grid covers 92% of all cities with over 500,000 residents, creating a half-day living circle in a truly unified national transportation network. What's even more worth noting is how infrastructure is quietly reshaping the economic development models of both nations. In China, the transportation network is deeply embedded into regional coordination strategies. High-speed rail isn't just about getting people from point A to point B. It's fueling industrial upgrades and population mobility along its corridors, helping major initiatives like the Chengdu-Chongqing Economic Circle and the Yangtze River Delta Integration Plan take root and thrive. Meanwhile, in the U.S., aging infrastructure has kept logistics costs stubbornly high, limiting the economic potential of the Midwest and widening the gap between regions.
The Department of Transportation estimates that the U.S. needs to spend at least $124 billion a year to keep roads and bridges in good condition. In 2010, all levels of government combined only spent $100 billion, $24 billion short.
This contrast reveals a deeper truth. World-class infrastructure isn't just a hard asset, it's also a form of soft power that defines national competitiveness. While China is already planning for intelligent railways and magnetic levitation trains, the U.S. is still stuck debating how to fix what's already broken. This generational gap in infrastructure development may have only just begun to show. Cost is another major factor. China's Three Gorges Dam, the largest hydroelectric project in the world, was completed in just 17 years. The Three Gorges Dam because it has an exceptionally large solid granite river valley. In the first segment of the river, about 1 million square kilometers of land has been taken under control, and the average amount of water passing through the river each year reaches 500 billion cubic meters. It is the world's most gigantic concrete structure. It took 40,000 employees. They needed nearly 6 billion gallons of concrete and 463,000 tons of steel, which is enough to construct 63 Eiffel Towers. They installed 32 huge generators that weigh 6,000 tons each. With the activation of these 32 generators, the Three Gorges Dam has reached its full capacity. These 32 main turbines, each with a capacity of 700 megawatts, and 2 small turbines, each with a capacity of 50 megawatts, can generate enough electricity to run 15 nuclear reactors, weigh enough to provide energy for 60 million people. The total cost? According to China, it cost $37 billion to complete the project. Now compare that to California's high-speed rail. Back in 2008, it was originally budgeted at $33 billion. But today, the price tag has soared to nearly $128 billion. And after 15 years, only a small portion of the rail line is finished. So why such a massive gap? In China, centralized planning allows for faster land acquisition and streamlined approvals. In the U.S., infrastructure projects often get stuck in years of lawsuits, community opposition, and political gridlock.
What is the state of infrastructure in this country today?
We are really falling behind and falling apart.
Marcia Hale is with the bipartisan group Building America's Future, which raises awareness of the state of U.S. infrastructure.
We've got a construction site right ahead of us here.
The American Society of Civil Engineers gave the U.S. a D+ for overall infrastructure this year after a comprehensive review that included the nation's roads, bridges, and waterways. Their solution? Invest an estimated $3.6 trillion by the year 2020.
Our roads, our bridges, our schools.
It is also time to rebuild our crumbling infrastructure.
America, this is how we truly build back better.
China is also leapfrogging in tech. Their floating tunnels and 3D printing technology are pushing engineering boundaries, while U.S. infrastructure often relies on decades-old technology. For example, China's Beidou navigation system, a rival to GPS, powers smart infrastructure projects nationwide, from traffic management to disaster prevention. So it means that precision guidance systems cannot be controlled or jammed by the U.S. anymore. The ICAO has now recognized China's Beidou navigation system as a global standard for civil aviation, which is more accurate than the American GPS. The fact is that the Beidou system has already been used worldwide and has an astronomical number of users. In the U.S., many cities still struggle to upgrade basic systems, like lead pipes and water supply networks. What drives these differences? It boils down to policy, funding, and culture. China's 5-year plans allocate massive state funding to infrastructure, while the U.S. depends more on fragmented local budgets and private investment. Culturally, China values long-term planning, as seen in projects like the Belt and Road Initiative, which aims to connect Asia, Europe, and Africa over decades. In contrast, U.S. infrastructure often prioritizes short-term political goals, leading to delays and budget overruns.
Just a few years ago, the stock market's at 25,000. Corporate profits are the highest they've been in decades. The rich keep getting richer. And our friends on the other side said, what do we do now? Let's do a tax cut where 83% of it goes to the top 1% of the wealthiest people. Fast forward a few months, global pandemic, 36 million people unemployed, 40% of families who have a worker that makes $40,000 a year and less lose their job last month. 4 million people didn't pay their rent, and the Republican Party says, we don't have any money to help you. Are you kidding me? Where do you guys live? Food lines around the blocks at our food banks in the United States of America. 1 in 5 kids are going hungry. Your party can't even get food to them. This isn't a wish list. If it's a wish list, it's for the working class people.
So, who's winning the infrastructure race? The answer isn't simple. China's rapid growth has raised concerns about environmental impact and debt risks, while the U.S. is finally investing billions in the bipartisan infrastructure law.
After years and years of infrastructure week, we're on the cusp of an infrastructure decade that I truly believe will transform America.
The $1.2 trillion bill includes $550 billion in new spending, including $110 billion for roads and bridges, $25 billion for airports, and the largest federal investment in broadband ever, $60 billion. All of this is extremely important and needed, with the biggest investment in bridges since the interstate system. With former Vice President Harris presiding, all 50 Senate Democrats voted to support the bill, along with 19 Republicans, including Minority Leader Mitch McConnell. It's a good day. Elections matter. But the bipartisan spirit in the Senate was gone by lunchtime, with Democrats taking their first procedural vote on a separate $3.5 trillion budget bill packed with other priorities that they intend to pass in the face of united Republican opposition. This budget resolution is a dream for those who want to socialize America. It's a nightmare for working people. But one thing's clear: the way these two giants build their futures will shape global economics, trade, and technology. In the field of hydraulic engineering, China has also achieved global acclaim. The South to North Water Diversion Project, the largest water transfer system in the world, aims to alleviate severe water shortages in northern and northwestern China. Divided into 3 routes, eastern, central, and western, the project reallocates abundant southern water resources to water-scarce regions across the country. The total length of the engineering project is 1,100 kilometers, and the total investment exceeds $62 billion. To date, the project has transferred hundreds of billions of cubic meters of water, benefiting hundreds of millions of people, while effectively improving ecological conditions and the overall quality of life in the north. Throughout the construction process, engineers face major technical challenges such as tunneling under the Yellow River and managing expansive soils. Yet through persistent research and innovation, Chinese engineers overcame these difficulties and ensured the successful completion of this national megaproject. China's rapid rise in infrastructure, it's no accident. Behind it, a deep foundation in science and technology and a vast reserve of skilled professionals. The country boasts a massive team of highly qualified researchers, engineers, and technicians who continuously drive innovation in the infrastructure sector. At the same time, China's industrial system powers the build. From cutting-edge materials to precision machines, it delivers at scale. In addition, China's infrastructure boom didn't happen by chance. It was driven by long-term government planning, strong policies, and massive public investment. One successful megaproject after another. Compared to the United States, China has demonstrated a unique set of advantages and growing competitiveness in infrastructure development. While the U.S., once a pioneer in global infrastructure, now struggles with aging facilities, funding shortfalls, and bureaucratic delays, many of its roads, bridges, and railways are in disrepair and badly in need of upgrades. In contrast, China continues to invest heavily, accelerate innovation, and complete projects with unmatched speed and precision. Its infrastructure model not only supports robust domestic development, but also offers a valuable reference for other countries seeking to modernize their own systems. And the story is far from over. The miracle of Chinese infrastructure continues to unfold. In the years ahead, China is poised to explore ever deeper underground engineering, expand transportation networks to new frontiers, and take on construction challenges in even more complex environments. With fearless determination and world-class technical expertise, China is reshaping the very definition of what human engineering can achieve, paving the way for a future that is stronger, smarter, and more interconnected than ever before. Do you think China's model can work in other countries? Or does the US have an ace up its sleeve? Imagine this. Beneath the roaring waves of the Lingding-Yang Strait, 33 massive immersed tunnel segments, each as tall as an 8-story building and weighing 80,000 tons, had to be aligned and joined together with Lego-like precision. The margin of error? No more than 5 centimeters. The difficulty? Comparable to threading a needle through a moving aircraft carrier during a hurricane. This was the hell-level challenge Chinese engineers faced while building the Hong Kong-Zhuhai-Macau Bridge. John Smith, a member of the American Society of Civil Engineers, once said, "Achieving millimeter-level precision in deep-sea immersed tube joints. We used to think that was impossible in the real world." Faced with such skepticism, even ridicule from overseas experts, Chinese engineers responded with quiet determination. Yes, the difficulty is unprecedented. Millimeter-level tolerance in these conditions is an enormous challenge, but that's exactly why we must do it. This is our responsibility as Chinese engineers. We will not be intimidated by mockery or doubt, and no technological blockade can stop our progress. We will stay on site, research day and night, and even if we fail thousands of times, we will never give up. And they didn't. Through relentless effort, they invented a technique called composite foundation treatment, injecting special materials into the seabed to turn soft silt into rock-solid support, capable of holding tens of thousands of tons. During testing, engineers worked 72 hours non-stop, failed 137 times, until they finally achieved a 300% increase in load-bearing capacity. On May 2, 2017, during the connection of tunnel segments E29 and E30, a sudden tidal surge knocked them 3 centimeters off alignment. In that critical moment, China's self-developed dynamic hydraulic adjustment system kicked in. and within just 15 minutes performed a millimeter-level correction. This move didn't just save the project, it rewrote the rules of sea-crossing tunnel construction worldwide. Today, the 55-kilometer-long Hong Kong-Zhuhai-Macau Bridge is not only the longest sea-crossing bridge in the world, it's a bold symbol of China's engineering prowess. Next, let's talk about water engineering. The Hoover Dam was once a global icon of industrial might, its power output unmatched for decades. But today, China's Baihatan Hydropower Station has taken center stage. Its network of underground chambers stretches over 217 kilometers. That's the length of 300 Empire State Buildings stacked end to end. The largest cavern is 438 meter long, 34 meter wide, and 88.7 meter tall. Hence can easily accommodate 13 Boeing 737 aircrafts. And in terms of output, it generates 3 times the electricity of Hoover Dam. Even more astonishing, while America's Big Dig in Boston went 220% over budget and suffered decades of delays, China built Beijing Daxing International Airport, a massive starfish-shaped megastructure, in just 4 years. It handles 200,000 passengers a day and secured 60 international patents in the process. From cross-sea bridges to hydropower giants, from high-speed rail networks to clean energy megabases, Chinese engineers are pushing boundaries again and again, turning the impossible into reality. They are building, quite literally, the backbone of a nation's rise. These projects show that China doesn't just export infrastructure, it exports a complete development solution. Even the New York Times admitted, Chinese infrastructure is reshaping the global economic order. So how is China defining the next century of human progress? While the US is still fixing highways from the last century, China is already exploring the ultimate future of infrastructure. China continues to overcome world-class engineering challenges through innovative techniques and advanced construction methods, earning it the moniker infrastructure maniac. Moreover, China has undertaken major projects in numerous other countries, each emblematic of its development drive. Behind China's global leadership in infrastructure lies not only a leap in technology, but also the support of a mighty nation. For over a century, from the devastation at the founding of the People's Republic of China, it has been the successive struggles of generations of Chinese engineers that have painted the picture of today's prosperous China. And yet, this is not the end for China. In the future, the infrastructure maniac will continue to help more developing countries modernize, create new opportunities for development, and build a better, more livable world for all. Each bridge, every road, and every project connects cities and countrysides, the present and the future, China and the world. Chinese infrastructure has not only reshaped the face of China, but also exemplified the strength, spirit, and speed of the nation. The infrastructure maniac will never stop. What miracles do you think Chinese infrastructure will create in the next decade? Please share your thoughts in the comments. Don't forget to subscribe and hit the notification bell. See you in the next video.